Okay, good morning. Welcome to
FamilyMath452a.
452a. FamilyMath452a. So today we're going to talk about the Collatz conjecture because you both said in your math biographies, when I asked you for a favorite unsolved problem in math, you both said the Collatz conjecture. So how does, but you both were a little struggling to remember how it works. So how does it work? What do you do?
Well, you pick a number, or an integer.
Okay, so we'll just call that x for now.
And if x is even, you divide it by 2.
If it's even,
you divide it by 2.
Take x divided by 2.
And then if it's odd, you multiply it by 3 and add 1.
If it's odd, you multiply it by 3 and add 1. Okay, what happens when you take an odd number, multiply it by 3, and then add 1?
It becomes an even number.
Okay, and what happens when you take an even number and you divide it by 2?
Well, it could still be an even number, or it could become an odd number.
Yeah, can you explain why that is? Why an even number divided by 2 isn't necessarily
it
odd or even?
Divisible. It could be divisible by like 4, 8, or 16, in which case you could divide it by 2 like again.
Okay.
But when in the dividing by 2 process, it'll always come down to an odd number.
Eventually.
Yep.
Yeah. Oh, that's a great observation. Why does that happen? Why when you divide by 2, even though you might not get an odd number right away, why will you always eventually get an odd number? Can you explain that?
Because either you're going to end up at 1, which is an odd number, or the number is 2 to some power times something.
Okay, yeah. So
You'll end up at that number, or you'll end up at 1.
that's a great observation. So right, it comes down to how integers factor.
Yeah.
There's going to be some number of 2's in any number, but it's always going to be a finite number of 2's, with one exception. Except for infinity. Mm-hmm. Right, so any finite number only has a finite number of 2's, and you can divide those out, and once the 2's are gone, you're either at 1
or an odd number.
or at some other odd number greater than 1, in which case you go back to here. Because on the Collatz conjecture, once you get to 1, you stop.
Yeah.
Okay? So let's do an example. Pick a small number, and we'll go through an example real quick.
How about 7?
All right. Yeah, 7's actually a great example because it goes on for a little while. 7 goes to
There's the 22.
22, which goes to, when it goes alternate. 22 goes to 11. 11 goes to
34.
34 goes to
17.
17 goes to
52.
which goes to
26.
which goes to
13.
which goes to
40.
which goes to
20.
to
10.
Which goes to 5. 16.
Wait.
Oh.
16.
And then 8, 4,
8.
2, 1.
Okay.
8, 4, 2, and then 1. And let me show you why you stop at 1. Because what would happen if we continued?
Well, then you go to 4.
And then you go to 2, and then 1.
So it's a loop there.
Right, so once you get to 1, you're in a loop. And the Collatz conjecture, it basically says every starting point, no matter what number you pick, eventually goes to 1. And the alternate thing that could happen is there could be some other loop somewhere, like maybe, A to B to C to D to A to B to C to D, where there were some other numbers other than 1.
Solve the
And it would
Collatz.
just
Right.
get stuck there.
Right, and it would get stuck there, and that would be a counterexample to the Collatz conjecture, but nobody's ever found a set of numbers like that. And people have looked and looked and looked and looked and looked, and I don't even know how far they've looked up in the Collatz conjecture, but pretty far.
Yeah.
But this is an incredibly difficult problem. In fact, I've seen a quote, and I don't remember who it was from, but the mathematician said, we don't know enough about mathematics to be able to solve this problem yet. Which is a very surprising statement, because why?
There's tons. We know a lot about mathematics.
We know a lot about mathematics, and what's the math in the Collatz conjecture?
Simple arithmetic.
It's just adding and multiplying and dividing. Like, it really doesn't seem like it gets simpler than that. So we've looked at the Collatz conjecture a couple different ways in the past. So one way we looked at it was through music, and so I thought we would do that as a quick look. Okay.
All right.
Okay.